What's up, guys? Let's take a look at day 5 of Advent of Code. I was out sick yesterday, so today I'm catching up. I've done 5. Maybe I'll do 6 as well. And I'm glad I did 5 because it was a fun one. It's got 2 sections of input. First, we have these rules of the thing on the left has to come before the thing on the right. They can happen more than once, so 97 is before 13, 97 is also before 61, and 47. So they don't have to be directly before, they don't even have to be in there, but if they are in there, the thing on the right can't come first. Then the second half of our input is the content, which we judge through the rules above, and even in the big data, they're not that big, they're like, maybe 20 or something, with a bunch of rules above. So usually on these videos I do it and then I delete and retype while I explain, but today I'm catching up, so we'll make it a little faster. Here's what I wrote, and today I focused heavily on the type hints. I want to get better at these type annotations, especially stuff like generics, so we'll talk about that along the way. So let's see what we've got here. The main function opens it up, and usually when we parse, I just do one big blob, like get the lines and strip them. But in this case, our data is in 2 separate parts. Like the example, you can see we've got the rules, and then after a blank line, we've got I think they call them updates. So for that, I used one of my favorite functions called takewhile. We take while the bar or the pipe character's in there, and then when we're done, that part of the iterable is consumed, and the rest of F is the rest of the lines. So we've got top and bottom. Those still aren't parsed, they're just strings, but we parse them. I have a parse rules function which says, hey, I want a dictionary because I want to be able to give you something and look up what's before it. And that includes more than one rule, because if I see, like in the example, 97 is before this guy and this guy and this guy, I want to be able to say, 97, give me all the stuff that it has to be before. So that's going to be a default dict with a set, because we don't know the order. Like, I don't know if 13 and 61 are related to each other in some way, but I know that 97 is related to them. So they're not in order, but 97 to them is in order. And so we add them to a default dict. We never use the default nature later, really. I mean, I guess when we look something up, we might find an empty, but we're not relying on that, except right now we can add to it, okay? And then to parse the updates is a lot easier because they're just lists of numbers. I could actually probably just eval it, but we're going to say split on the comma, and then we turn them into ints. In hindsight, I could have kept them strings. I thought maybe we would use the int nature of it to compare, but we're only comparing through the rules of the top half, so I could have kept them strings, but no problem. So that's that. We haven't passed them into part 1 yet. We're not doing anything. That's just the parsing and setup, which is most of the work. Speaking of that, there's one more thing I wanted to do, because when we separate this into part 1 and part 2, they tell us that part 1 affects the good lines, the lines that are already in order, okay? The ordered lines. And guess what? Part 2 is the other ones. So we can split that up into those 2 buckets before we even do part 1 and part. We can just say, hey, part 1, you don't need to search through them to find the good ones. I'll just give you the good ones. And part 2, I'll give you the other ones, okay? And so for that, when I was making it, I thought, hey, there's a filter, and there's a filter false to get the other side, but there's not a filter both. And I understand why, because it doesn't really make sense as an iterator kind of thing, because you have to keep multiple things in state. But I made a filter true-false where you take a predicate. Here's where I got into my generic type annotations. So we're giving it a sequence of something, which could be strings or ints or whatever, and we're receiving two sequences or two lists of that. And so we're giving it a function that takes a thing and gives it a Boolean. So this is like, hey, I'm filtering odds and evens. I want to go through, and if you're an odd, I put you in the odd bucket. If you're an even, I put you in the even bucket. And then at the end, I give both to the caller to say, hey, now we have both. So I go good, bad equals filter with the order function on the updates. Remember, the rules don't have to be filtered. Those are true globally. So what's the ordered function? Let's take a look at that. Well, it is a thing that takes some rules and an update, and it tells you yes or no, is this one in order? So it's just doing one line at a time, which is often pretty short. And so we go through and we say, hey, on the first one, it can't go wrong. On the second one, it will compare the stuff I've seen to the stuff that should be in front of me. And if the thing I've seen should have been, in the future, well then, we're done. By the way, when I look at these rules, I don't know how comprehensive they are. Does this have every combo that I could see? Probably not. Does this have enough that I could compare? I hope. Does this get me stuck in loops when I compare a thing to a thing to a thing? We just have to try it and find out. So I'm going to say, as I look through my update is what we call the names are a little tricky because I think they're using update to mean like one number in these lists, where I used update to mean a whole line of this list because I didn't have a second dimensional plural. I didn't say update and then another updates for the line, and then what else do I do for the whole thing? Do I say updates with two S's? I don't know. So for that one, this just says if we ever find one that breaks the rule, where it's like, hey, look, we use our set intersection operator because they're both sets. We say, hey, if I've ever seen one that I shouldn't have, we're done. Even if it's on the second one of the list, like the second one could say, hey, 47, you're supposed to be before 75, therefore this whole thing is ruled out. Then we don't need to waste time checking the rest of the line. So then we kick out early, and if not, we add the one we just saw to the scene and do the same thing on the next guy. Beautiful. I was thinking about saying like return any scene intersection rules for blah blah blah, but then I wouldn't have got the benefit of early returns and short circuiting, So then we say, okay, we use that to filter the whole bottom updates. And if there are some good ones, which I think there always are at least some good ones, we send that to part one. Because what are they asking for? Well, part one says, take the ones that were good, that didn't require any changing, and give me the middle of each one. That is, I think, always an odd numbered amount, but it never gave me trouble, and I didn't really check. So we are taking, I think in the example, the first three were good, and then we add up the middles of those, so it gets 143. Let's see if that does it. And in fact, let's print good on the example just so we can see. Okay, so these three lines on the example were good, and yeah, it is the first three lines. So we add up the middles of those, meaning that my part one is just Nice, easy, simple, because we just sum map middle onto the good guys, which, what is middle? It's the ugly length divided by 2, integer, which I guess rounding down is always good enough, and we take that back into the index. So we map that onto the good ones. Beautiful. Now part 2. Part 2 says, okay, the other ones, that's why I did the filter true false thing, to have, if you do filter and then you have to filter again, that's kind of annoying. So this says the other ones in the other bucket, actually order them and then do the same thing. So rearrange them to be good like they were in part 1, and then do the middle thing again, just like we did in part 1. So that one is interesting because you run into the issue of how good are our rules? Are they just gonna leave us in the lurch sometimes and we try to compare two numbers and they don't give us anything? Are they gonna get us stuck where there's a contradiction of 47 supposed to be before 35, but 35 supposed to be before 47? Well, it turns out that for me it worked. Maybe some people got an unlucky combo in their inputs, but for me, here's what I did. I made a function called compare sort. Okay, I couldn't easily use a Python sort where you do a key, because the key is sort of a unary independent thing, which I'm sure is faster performance-wise, but this is more of like a JavaScript sort where you give it like two things and they compare. So what I do is I say, hey, give me the rules and give me a line, just one line, and then we do this very ugly thing, which I hate to do, the I and J range len. And so we say, okay, if we find somebody before you who was supposed to be after you, we got to swap. That's why we have to use the index, the ij, instead of looking directly at it, because the reference is straight to the thing instead of going through the list. Whereas if I said like for num in update, then it might mess me up if I mutate the list and keep trying to go through the list. I haven't tried. I don't like this kind of thing. But when we wrap it up in a function and nobody else has to look at any indices and nobody else has to think about I and j, then it's fine. So what happened was part 2, I can't just send it the good stuff. It also needs the rules. So I send it the rules and the bad ones, the ones that were not in part 1, and I tell it, hey, make those good. So sort those using the compare sort, and then send that into part 1, which is adding up the middles. I really enjoyed this problem. Let's run it on the big data just to be sure. So let's run it on the data. And you can see that it's fairly fast. Like, I run, boom, it's there. We may have suspected that this kind of search where you compare everything to everything would have been a week worth of processing, but no, it's not that bad. Partially because the lines aren't that long, but also because this is a pretty good setup. The only slow part is just calling functions in the first place, because Python function calls take a second. But otherwise, I mean, we kick out early on this one. We do this reasonably well. By the way, this compares everything to everything twice, but we need it. So this compares like the first guy to the middle, and then later it compares the middle to the first guy, and you might think, isn't that doubling the work? Can't we cut it in half? But the answer is no, because our rules only point in one direction. It says, hey, you should be before you, just due to the nature of a dictionary. When we're looking things up, we can't look to see if you're in the values of a key, or if we did, it would be slow. So I think this is necessary. Maybe somebody else out there has a cooler way of doing it. But I really enjoyed this problem, especially the functional stuff where I tried to organize it. And this main function is so nice and procedural and just does the stuff in order. But then the other functions have their job, which might involve ugly indexing. It might involve complicated types. It might involve stuff where I tried to avoid double comprehensions by throwing in a map or whatever. But in the end, it worked out nice, and I had fun with this one. Thanks.